Find the height of the mast. Mary is standing 30 meters from a mobile phone mast. The angle of elevation to the top of the mast is 40 degrees. You see from her foot there, 40 degrees there. Find to the nearest meter the height of the mast. So this is just a triangle, and it's a right angle triangle. There's our 90 degrees. So this side here is the hypotenuse. It's the longest side, and it's opposite the right angle. Opposite Mary there, we call that the opposite side. That's the height of the mast. Let's call that H just to make things. Well, no, we might confuse that with the hypotenuse. So let's call let X equal the height of the mast, right? So we're looking for X, and we know this side here, the 30 meters, and that's the adjacent. ADJENCT. So what do we know? We know the angle here. We know the opposite. We're looking for this opposite X here. So we could sketch that triangle again, maybe. With 40 here. We know we're looking for the opposite, and we know the adjacent here is 30. So we need a trig ratio. Sine, cos, or tan. They work for right angle triangles. We need one of them that works with the opposite and the adjacent, and it's going to be tan. Tan 40 degrees. It's two old angels is the way I remember. So opposite over adjacent. So I go over here and I go tan 40 degrees equals the length of the opposite, which we don't know. We'll leave X there for that. And the adjacent is 30. Now, multiply both sides of the equals here, both sides of the equation by 30, and you'll end up with 30 tan 40 degrees equals X. And we'll just put that into the calculator. 30 tan 40 degrees, and I get 25. X equals 25.17. Now we've gone far enough. We're looking for the height to the nearest meter. So 0.1, so we're going to round that down to 25 meters. That's the height of the mast to the nearest meter.